What are the other low-voltage Na-intercalating materials, such as Na2T307, Na3T2PO4, and Na alloys, that have also been investigated for use as anodes? And how do these materials compare to hard carbon in terms of performance? What is the practical reversible capacity of a hard carbon anode, and how does it translate to the formation of Na 0.67C6? Why is a reversible capacity of around 250 mAh per G considered practically useful, and what does this capacity indicate about the energy storage potential of hard carbon as an anode material in Na-ion batteries? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? At what voltage, specifically 0.25V versus Na/Na+, does hard carbon achieve this reversible capacity, and why is this voltage significant in determining the performance of the anode? What characteristics should electrode materials for Na-ion battery anodes possess to be considered effective, and why is it important for these materials to have low Na-intercalation and deintercalation voltages? What is meant by low Na-intercalation and deintercalation voltages, and why should these voltages preferably be below 0.5V versus the Na/Na+ electrode for optimal battery performance? Why is the Na-deintercalation voltage of the anode material particularly important in the context of Na-ion batteries, and how does it affect the overall charge and discharge cycles of the battery? How do the Na+ ions interact with the anode and cathode during the discharge process of a Na-ion cell? And why is the deintercalation of Na+ ions from the anode and their intercalation into the cathode a critical part of the energy storage mechanism? What is the significance of the difference between the voltages of the anode and the cathode during discharge, and how does this voltage difference define the overall cell voltage of the Na-ion battery? How does the design of anode materials with appropriate deintercalation voltages impact the overall efficiency, capacity, and stability of the Na-ion battery? In what ways might researchers continue to explore new materials or modifications to existing materials, such as hard carbon or low-voltage Na-intercalating compounds, to optimize the performance of Na-ion batteries for commercial applications? Why is the choice of electrolytes considered important for developing practical Na-ion batteries, and how does the electrolyte affect the performance and stability of the battery? What role do organic carbonate solvent-based electrolytes play in Na-ion batteries, and why are they commonly used?